Hello and welcome to the sling psychrometer. So this is just the scientific grade version. So it's got two thermometers that are in Celsius. It's got a little spinner so that I can swing it around, thus the name. It's got a wick on one side here that I'll wet. So it's going to be very similar to the student version one at the top and the bottom. It's got a dry bulb, which I'm going to not touch, and I'm going to keep dry. So when I get this wet, I'm just going to turn on the water here. Careful not to dampen the other one, so I just want to get there so there's enough water in it, on it. I'll squeeze a little bit out of it so that it drops off, but the more important thing is I want to read my temperature there so that the temperature is the same on both. And so right now I'm running right about 25, just a touch over 25 degrees Celsius on my dry bulb, and I'm running, this water is actually a little bit warm, so that works out good for us. About 26 degrees, 27 degrees on my tap water. Just by blowing on a little bit, I want to try to make sure that it's the same temperature. I can also warm it up by just barely touching the bottom here. So I don't want this dry wick, the wet wick, to be dripping wet. It just needs to be damp. So what I'm going to do with this little critter is I've got to spin it around for about 60 seconds. I'm not going to saturate the air in which I'm moving around, but basically what I'm doing is I'm causing advection to go across the wet bulb, which means wind. So any type of wind current will do this. The amount of time that I do this is not going to affect how much is evaporating. Well, technically how much is evaporating, but the rate in which it's evaporating. So there's just going to be a small amount of water vapor that's leaving this the wet wick as I go around and around and around here. And so this little critter spinning around is just allowing wind to go across the wet bulb. Now, if I have a really, really humid environment, hardly anything is going to be able to evaporate because there's already moisture in the air. If the air is dry, there's going to be plenty of moisture allowed to go into the air, and so it's going to evaporate quite a bit. So that evaporation is going to cool the surface, just like blowing across a hot thing of soup, or cooling off a drink. You just blow across the surface. Advection causes evaporation, just like in the earlier video, and then this has probably been about enough. I'm going to go and stop it here. So I'm going to take an immediate reading of the dry bulb. It is still at 25 degrees Celsius, so it shouldn't have changed. It was dry, there's nothing evaporating. But my wet bulb has now actually dropped down to 17.5 degrees Celsius. So you see I've actually dropped quite a bit. So that's going to be my depression, is the difference between 25 and 17.5. That's going to be what I use my chart on, and I'll be able to figure out exactly what my temperature is. To redo this, if I'm going to do another measurement, I want to make sure that my temperature comes back up on my wet bulb. I can do that again by just simply pinching the wet bulb there a little bit to let my body heat warm it up. I don't want it to overshoot too much, but as it starts warming up, slowly returning it back is exciting. I can see it, you can't. So we're back to 25 degrees. I just want to make sure that it's damp. It doesn't have to be dripping wet, but if you have to re-wet it, just a touch under the water there is fine. It doesn't need to be flinging water off. It doesn't hurt if the water's flinging off. It's just kind of annoying. But that is how our little sling psychrometer works.